Hello again, my regards. I wish you enjoy this part 2 of my autobiography. Adolescence to Youth. My time as a teenager. Life, however, through its challenges. My relationship with formal education became more strained as the years passed. In my teens, the disconnect between my way of thinking and rigid teaching methodologies became so pronounced that I left the Luitpold Gymnasium in Munich. I needed a place where my thoughts could roam freely. We moved from Germany to Italy and then to Switzerland. When I was 15, my family moved to Italy due to economic difficulties, but I initially stayed in Munich to finish my education. It wasn't long before I dropped out of school and joined them. I decided to continue my studies in Switzerland, where I eventually graduated from high school in Aarau and then entered Zurich Polytechnic. Switzerland attracted me very strongly. The liberal educational approach of Swiss schools caught me. In Aarau, I finished my secondary education very well, and the atmosphere there was a breath of fresh air. I thrived, not only academically, but also personally. During my adolescence and early adulthood, my life was filled with discoveries, challenges, and changes. Education and challenges. In Munich, I attended the Luitpold Gymnasium. Although I was not a big fan of the authoritarian education system of the time, it was here that I began to develop a deep love for mathematics and physics. However, I did not always perform well in all subjects. My view on religion. At one point, I became extremely devout and religious. However, as I grew older and more exposed to science, I began to question traditional narratives and my perspective on religion transformed. Mileva. Meet Mileva. During my years at the Polytechnic, I met Mileva Marek, a brilliant physics student. She became an integral part of my life during those years and later my wife. Together we faced challenges, had deep academic discussions, and shared moments of happiness and sadness. The formative years. These years, from my adolescence to my young adulthood, were crucial. They laid the foundation for my future discoveries and gave me the tools and mindset to challenge accepted norms in physics. In short, although I faced challenges and difficulties, these early years were instrumental in molding the scientist and man I became. They were the foundations of the architecture of the scientist who developed and grew. After Zurich Polytechnic. After completing my studies at Zurich Polytechnic, I entered a phase of my life full of challenges and achievements. Despite graduating as a high school teacher in math and physics, I struggled to find a job in teaching. My teachers didn't always have the best impression of me because of my questioning and often rebellious nature. Finally, with the help of a friend, Marcel Grossman, I got a position at the Bern Patent Office as a technical examiner. This work, though far from my academic aspirations, turned out to be a blessing in disguise. It provided me with a steady income and, surprisingly, plenty of free time to think and write about physics. Here, in my lazy hours, as I used to call them, I was able to reflect on many of the ideas I had accumulated during my years in Zurich. Marcel Grossman was, in addition to my classmate at the university, a very close friend until his death in 1936, despite marked differences in personality. In college, Grossman was formal and respectful while I was unpredictable and rebellious. The main collaboration between Marcel Grossman is known as the Einstein-Grossman paper, a step in the direction of what would become the general theory of relativity, published in 1913. The wonderful year. 1905 was what I would call my miracle year, annus mirabilis. In that year, I published 4 papers in the journal Annalen der Physik addressing topics such as the theory of special relativity, the equivalence between mass and energy, and the photoelectric effect and Brownian motion. These works laid the foundation for many of the modern developments in physics and eventually brought me recognition in the scientific community. Swiss Patent Office. Although I was working at the Patent Office, I continued to look for academic positions. After my miracle year, and with the gradual recognition of my works by the academic community, I finally got teaching positions, first in Prague and then in Zurich. Mileva and I had children and faced several challenges in our personal relationship. Although we were united by our passion for physics in our early days at Polytechnic, over time, our lives took different directions. During these years, I continued to develop and refine my theories, which eventually led me to present the general theory of relativity in 1915, an extension of my special theory of relativity. Despite the many challenges, both personal and professional, I never stopped questioning and exploring the beautiful tapestry of the universe. While working at the patent office in Bern, many ideas were floating around in my head. Often, between examining patent applications, my mind wandered into the depths of physics. Although office work might have seemed mundane to many, for me it was a respite, a space where I could reflect and focus on complex problems without the distractions of academia. During that year, I wrote and published 4 papers that would change the course of physics. The photoelectric effect. On a heuristic view of the production and transformation of light, here, I introduced the idea that light could be described as discrete packets of energy, or quanta. This idea would be fundamental to the development of quantum theory and would win me the Nobel Prize in Physics in 1921. Brownian motion. On the motion required by the kinetic molecular theory of heat of small particles suspended in a stationary liquid. In this paper, I presented an explanation for Brownian motion, which provided convincing evidence for the existence of atoms and molecules. Special relativity. On the electrodynamics of moving bodies. This is, perhaps, my most famous work, where I introduced the theory of special relativity. Here, I propose that space and time are intrinsically intertwined in what we now call spacetime. Does the inertia of a body depend on its energy content? In this short article, I introduced the world's most famous equation, E equals mc squared, which describes the relationship between energy, E, and mass, m. Looking back, I feel deep gratitude for having had the opportunity and ability to explore these concepts, and I am amazed to think about how those moments of reflection in Bern shaped the understanding of the universe in the 20th century. This concludes Part 2 of the series. Part 3 follows. The general theory of relativity. No longer the product of a wonderful year but of a sustained mental effort, my brain muscles to the maximum. See you soon.